Oftentimes in the networks we deal with, we didn't create the network. We're just called in to fix it or configure it or troubleshoot it. In this example, we're going to go through a troubleshooting exercise that Eric, courtesy of the Cisco Learning Network, provided as a challenge. It was a fantastic lab. It involves 3 simple routers and tons of great problems. Join me as we walk through the process of troubleshooting. So our goal is full reachability here. So let's start with the basics. Can R1, let's just go to R1 and take a look at its routing table. Do a show IP route and just take a look at what's going on with this guy. So the first problem off here that I see is that R1 only knows about one directly connected route, and that's its loopback. That implies that this interface is either shut down or doesn't have an IP address configured on it. Let's do a show IP interface brief just to verify, and sure enough, FA0/1 is shut down administratively. So we can fix that real quick with interface FA0/1 and tell it to wake up, just like that. So now if we do a show IP route, we should have at least the 2 directly connected networks, the 10.1.13 and the loopback interface. That's great. Now, as far as full reachability and connectivity, let's make sure that R1 has reachability out to this network right here, the 10.1.45, because that's what I'm going for. I think the lab was asking just for R4 to be a DHCP client, but I wanted to go for full reachability. So with R1, let's see what routing protocols he's running. It's real simple. We just say, please show me any dynamic routing protocols. So show IP protocols shows us that nothing is running. Now before I go start configuring routing protocols, let's take a look at R3 just to make sure that there's not a routing protocol in place, and R4 show IP protocols. Okay, so there's no dynamic routing protocols whatsoever, and I'm going to put one in place. The simplest one to put in place is probably EIGRP. So router EIGRP will use Autonomous System 1, no auto summary, and we'll just say I want to do network everything, and that's it. I'm going to do that on all 3 routers so that when neighborships come up, or if they come up, I'll know, hey, you know, my network is functioning. I've got neighborships with EIGRP, and I've got basic connectivity as a result of that, you know, those messages. So on R3, we'll go into configuration mode. By the way, that's just a little alias for config T, the C is, so I don't have to type in config T over and over again. And we'll do router EIGRP1 and say no auto summary. And we'll put in a network statement that says, please include all possible interfaces. And we'll do the same thing on R4. Missed a 0. All right, there we go. So now my routing protocols are at least in place and ready for neighborship. So let's go back to R1 and see if we have a neighborship, which we don't. There's no console message. But if we want to do a show IP EIGRP neighbors, we've got nothing. So let's just verify that R3 is happy and has an IP address on it. So the show IP interface brief, looking for FA0/1, there it is. And it has an IP address, but it is shut down. So we'll fix that. And no shutdown. Okay, so if the interface comes up, which it just did, oh, and we have an adjacency. Look at that. We have an adjacency. Well, that's great news. Let's just verify that we can ping our neighbor. Now, the adjacency would appear that our neighborship is good to go. However, the multicast that we're using with EIGRP doesn't involve directly the MAC addresses of each neighbor. So let's just do a ping over to this guy's IP address right there of 10.1.13.1, just to verify that we can ping him. And we can't. So let's see if there's an access list. That could be stopping us. Let's see if there's an access list on this interface that's denying inbound ICMP replies, and that would stop a ping from working. So the show IP interface for FA0/1. And it says here that we have no inbound access list set. Well, we also could have an outbound access or an inbound access list on R1, stopping the inbound ping requests. So let's do a show IP interface for FA0/1 on R1, and no ACLs there either. Okay, so this is interesting. Let's do a show IP EIGRP neighborship, and it shows us that we have a neighbor. And look at this hold time. Oh, look at that. We just lost him. Okay, so we lost the neighborship and then they came back. Now, what that implies is that we have a problem with unicast traffic between those two devices because the hello messages go out multicast, but they do use unicast back and forth to keep track of each other as well. And the unicast is not working. So let's verify why these two devices can't talk to each other. The IP addresses are correct. EIGRP is running, which is irrelevant to this discussion at the moment. We've got the ability to see each other's neighbors, but why can't we ping each other? Access lists are not in place. Let's take a closer look at what's going on. If layer 2 isn't happy, layer 3 isn't happy. Let's do a show ARP. Look at the ARP cache. So there's the IP address for 10.1.13.3, and there's the age time. That's cool. And that's the MAC address, I'm assuming, of R3. Let's go take a look. So C202. We'll do a show interface for FA0/1. Oh, let's take a look. Is that MAC address right there? C2020204. Is that this guy? C2020204.001. And that looks perfect. Okay, so the MAC address that we have here on R1, cached, that we learned via ARP, is accurate for what R3 is. Let's take a look at the other side of the fence. On R3, if we do a show ARP, here it shows us that we have a resolution for 13.1, which is R1, but check this out. See how it doesn't have an aging time here? This hardware address, the MAC address, was not dynamically learned. If it was, it would automatically show an aging time of 0 minutes or 1 minute or 10 minutes or something else. But there's a dash. That means it basically wasn't learned. It was hard-coded, and guess what? I'll bet you that MAC address right there doesn't match what the MAC address of R1's interface really is. So this guy ends in 1111. Let's go to R1, take a look. Show interface FA0/1. And see how this does not end in 1111? So there is a static entry, it appears. Let's go take a look on R3. So to verify that, we do a show, run. Please include anything that has the word ARP in it. And if there's a static ARP, it'll show up. So we can just get rid of it. We'll say no. We'll copy this, paste it in, and verify our work. With the show, run, include ARP, there shouldn't be any ARP entries. Now, what we should be able to do is do a show ARP. And there we go. So we have cached 10.1.13.1. The aging time is 0 seconds because we just learned it. And we should be able to ping that address now as well. So I'm going to ping and I'm going to copy that just so I don't do a typo. All right, the ping works. Great. Okay, R1 and R3 can talk to each other. Let's go back to R1 and do a show IP route and just verify that we have an EIGRP learned route as well. Great, that's the loop back on R3. So we're making progress. Now let's move further down. This little portion of our network seems to be okay. Let's go to R3 and R4. Now R4 is going to be a DHCP client. So here's what I would do. Just to verify that this segment right here is solid, we could temporarily put an IP address on this interface just to make sure we can ping R3. And that's what I'd recommend we do. Because if we don't have all the cables in place or this switches 2 different ports in 2 different VLANs, we could have other issues at physical layer at layer 2 before we even get to layer 3. So let's just put an IP address on, verify we can ping, and then we'll go back and take a look at the DHCP. So on R4, we'll go into interface FA0/0 and do an IP, make sure it's not shut down. That's always good. And we'll do an IP address of this network segment, 10.1.45. I wonder if it's really 45. Let's go take a look real quick at R3. Show IP interface for FA0/0. Okay, that interface is 10.1.45.3. So this would be 10.1.45.4 if we want to follow the same naming convention or numbering convention. So 10.1.45.4 with a 24-bit mask. All right. Now, because EIGRP is running, if that works, and we have connectivity between these two guys, we should have an EIGRP neighborship form, which I'm not seeing happen. And that's because I was on the wrong interface. Oh, no, it's FA00. That's right. Interesting. Let's do a show IP interface brief. And it looks like FA00 is up right here, and it has an IP address. Let's just take a look at the other side as well. We'll go back to R3 and do a show IP interface brief. And, oh, it's down. And that would explain why we can't talk. So let's go bring that interface up. And we should get, there we go. And there's our EIGRP neighborship. And just for grins, let's verify we can do a ping. We'll do a show ARP. We've resolved him already. He's right there. So we'll ping that address. Okay, so that's great. That means that the switch is not part of our problem, which it could be, and we have basic connectivity. So let's go back to this client, R4, and we're going to make him a DHCP client. That was the original task at hand. So go back to R4, go into interface FA00, and we'll say IP address, I want to use DHCP. Now at this moment, he's sending out a DHCP discover message looking for a DHCP server. Now R1 is our DHCP server. So as a result, the broadcast sent right here is going to fall on deaf ears unless R3 is set up as an IP helper. And we also have a message saying that neighbor 10.1.45.3 is not on a common subnet. Wow, let's take a look at that. Neighbor, it's saying that this neighbor right here is not on a common subnet. Maybe we got an IP address. Let's just check real quick. Show IP interface brief. Now, we have no IP address. That's so amazing. Check it out. What's happening is R3 is sending these hello messages, and because R4 is running EIGRP on this interface, which is really weird, show IP EIGRP interface. Because it's running EIGRP in this interface, but it doesn't have an IP address, which is super weird, it's hearing the hellos from R3, and because R4 doesn't have an IP address, it's saying, wow, that's not the same subnet. Yeah. A network is not the same as zero network, which is super weird. So I'm going to turn that off for a second. No router, EIGRP1. So that'll go away, and that's super weird. That's also a common mistake, by the way. If you have two neighbors who have incorrect IP addresses and they're sending out their hello messages, that message indicates that you simply have two devices connected to each other with not agreeing masks and not agreeing networks between the two of them. Okay, so let's take a look at R3 and see if the IP helper feature is set up. R1 should be our DHCP server. We can verify that real quick right here. Let's do a quick show run and verify we have DHCP configured. There's a couple pools. We have a pool called test, which is accurate for the 45 network, and we have a pool called R4. Okay, so we have two pools, and looks like we have a reservation for this client identifier right here. So I don't see any problems initially with this, except I don't see a default router. Oh, check this out. Check this out. This pool right here is pointing to a default gateway of 10.1.45.33, which is not R3's IP address. So R4 wouldn't have a default gateway. And this pool R4, where he has the reservation set up, that doesn't have a default gateway at all. So here's what we're going to do right here. Before we get too far, let's go ahead and get DHCP working, see which IP address is given to R4 from the DHCP server, and then we'll come back and tweak and tune the pool or pools as we need to. So on R3, let's set up, our IP helper, interface FA0/0, and that's right here. We're going to say IP helper address, and the helper address is going to be pointing over to R1. So 10.1.13.1, just like that. So what's going to happen is this, hopefully. R1 will do a broadcast saying, I'm looking for a DHCP server. R3's helper interface will see that on this segment of our network, and it will take that request, forward it as a unicast over to R1. R1 will say, great, thanks for the info. I have a beautiful IP address. And R1 will respond back and forth with R3. R3 will respond back and forth to R4. So R4 really doesn't even know that the DHCP server is not local. It's a big joke on R4. So now that the helper interface is all set up right here, let's go back to R4 and verify it works. So we'll do a show IP interface brief. Oh, there we go. Didn't have to wait. So it got an IP address, and it got 10.1.45.4. Is that the one we had reserved for it? Let's take a look. 10.1.40. No, it isn't. So it didn't get this guy right here, and I'm totally okay with that. It took 10.1.45. What we do need to do is correct the default gateway. So I'm going to remove this pool. That's what I'm going to do. I'm going to say no, IP DHCP pool R4. It's gone. And I'm also going to go and modify this one. And I'm going to say this, boom, IP, the pool test. And let's just do a real quick modification. I say no, get rid of the wrong router. No default router this. Now, if we run EIGRP on R4, we don't need a default route because he's going to learn all the networks. But if we wanted to provide one, the correct default route for R4 would be R3's interface F800. So let's add default router. And we'll say it's going to be 10.1.45 dot, and we'll go with 3 because that's what it is. And let's go back to R4 and let's release that. And for me, the quickest way to do that is we could do a no IP address. You could also shut it and no shut it. That would do it too. Let go of that address, IP address, DHCP. And that'll trigger the process as well. So now R4 is broadcasting, R3 is forwarding, R1's getting an IP address from the pool it has, handing it back, and we got the same IP address again, which is just a quinky dink. So let's take a look at our default route now. Show IP route, there we go. Our gateway of last resort is 10.1.45.3. Now we haven't solved the problem yet of full connectivity. Because now R1, if we go up to R1, can we ping 10.1.45.4? I believe we can. There might be some timeouts with ARP and so forth. But so we have basic connectivity from R1 to R4, but we don't have connectivity to this loopback interface. Why? It's because that loopback interface is not being advertised anywhere. So we could do a static route on R3 and R1, or we could just tell R1, join the party. Even though you have a DHCP assigned address on FA00, let's run EIGRP, include this loopback, include this interface, and that way you'll be able to share that with others. So to do that, we'll go into router, EIGRP1, no auto summary, and then I'm going to put just a couple network statements in. Network 44, 44, 44, 44. And what that says is I want any interfaces that match all those 32 bits. So there's that one interface. We do a do show IP EIGRP interface. And there we go. So that got loopback 1. And I'm also going to add this interface here. I'm going to say network 10.1.45.0. And I also could have put a 4 at the end, and that would have worked with all zeros as well. And we'll just verify that I got that interface. Okay, so now both interfaces are there. EIGRP converges faster than any other routing protocol on the planet. So now if I do a show IP route on R1, we should have all the routes. And there they are. So if I do a ping all the way to 44.44.44.44, and I source that puppy from 11.11.11.11, which is local to R1, we've got full connectivity all the way across. And then that was that other reservation that was set up for R4, and I suppose we could look at that closer and troubleshoot that. But for the goal of full connectivity, we are set. We had down interfaces, we had incorrect layer 3 to layer 2 mappings because of static ARPs, and we had the missing DHCP or the IP helper function on R3. So I want to thank Eric for a great lab, putting it out there for everybody to work on. It was very fun to go through, and I wish everybody the best of success in all your troubleshooting and all your studies. Have a good one. Bye-bye.